Welcome back to another programming video. Today's topic is going to be loops and repetitions. For this lessons, we are using Python as our main programming language. Feel free to use any other language you're comfortable using. I believe the principle would be and should remain the same. Now, let's jump straight into the code. Now, this is our setup. I'm using Visual Studio Code. There are many ways today to go about running Python. One of them being even online. There's some free platform online that provide such capabilities, and also ease of use, so you don't have to struggle with stuff that really do not add to your learning path at the stage until such a time as that. Now, why use loops? Loops, as the word suggests, you want to loop, repeat, do something again and again and again. Ideally, what you don't want to do is write a code and that does one thing and rewrite the same code again that does the same thing multiple times. So that means you might end up with thousands of lines of code for something that a loop can do for you in a single pass, or single or 2 lines or 3 lines of code. Now, loops have the 2 options. There's a for loop, or you can use a while loop. And the difference will be seen as we go about using some example down the line. But at a high level, for loop is basically if you know what it is that you want to loop through, or how many times you know you're going to be looping through. So basically you're saying for within 5 loops, repeat this 5 times or repeat that 10 times. That's very specific. And once the loop is completed in those 5 times or 4 times, whatever the number of time is, then the loop stops. And that's it. That's the end of code. Versus a while loop, you have a condition that allows a loop to run endless time until the condition changes. Either the value is less than 5, or there are many conditions that you can set for the while loop to keep on running for a specific task. Now, I'm going to start using the for loop, and for that, I'm going to be relying heavily on the inbuilt function called range. Now, this comes inbuilt, you don't have to install it, and that's the beauty about Python and the multiple libraries that run behind the scene. Hence why we always talk about version Python 11, version Python 12, and then because all those versions come with some updated packages or inbuilt functions that are just reusable, so you don't have to reinvent the wheel. It's just easier that way than having to code and rewrite the whole range. It just doesn't make the learning, especially something like this, it makes learning even more complex and difficult, because you're stumbling into something that you may not need in the beginning, but later on, as you get more insight and more knowledge about some principles, it becomes easier to then dive into those areas where you can start rewriting things like range and all of that. So we're going to use that. Range relies on 3 variables, so you need to pass them. One of them is required. That is going to be the stop, because like in this case, I pass 1 and the range will run, but it will consider the value that I've passed as the stop. So it's going to be from 0. 0 is the default start if no start has been passed in as a variable. And the stop is basically the number that I've passed in. It's always going to be that case. If it's 1 value you're passing, you're only passing the stop. And if you're passing 2, you're passing the start, when to start in the range and where to stop. And if you're passing 3, you're passing the start, stop, and the steps. Steps meaning 1 step or 2 steps or 3 steps. Totally up to you. So I just thought I should bring that up there. So we've already clarified that the default start is always going to be 0 if you're not passing the start position within the range. And the range is because it starts from 0, so you're always going to have these. Like in this case, we're passing 5, we're getting 0 all the way to 4, because we're starting, the first value is going to be 0, therefore the last value will be 4, and that gives us a range of 5. I'm sure by now you're making sense. You can just count them: 1, 2, 3, 4, 5. That's a range of 5 starting from 0. Now in the second case, we're passing two variables. One is a start, the other one is the stop or the end if you prefer, and therefore we're starting by the value of 2 and there's no step, therefore the default step was going to be 1. So that's what we're looking at. So it's going to be 2, 3, 4, 5 and 5 and then move to 6. So what you're realizing here is that it does not include the value of the stop or this end. The value of the end is excluded, so therefore you see 5. That's an easy way to kind of go about remembering what will be the last value in this range that I'm selecting. Now the next two case or use case, I'm passing in the tree value, but in one case I'm putting steps, positive steps, in the other case I'm passing in negative steps. Therefore you just get the same behavior but in the opposite direction. So one is a count down and the other one is count up. So basically that's what we're seeing. Now back to what matters, the for loop. Now in this case I'm looking at a for loop and I've already explained what a range is, so you can anticipate what this is going to be and what we printed. Now the range is 5, so we're looking at 0 all the way to 4. And then I here represent the steps. Think of it as steps. That's the easiest way I can go about explaining this. So I can be any value, it can be S, it can be A, you choose it. In this case I'll just put I. So I value is going to be the step. The first step is going to be 0, like we see in the previous example here. So it's going to be 0. So that value, and I say for every value, for every step that you take within this range, print the value of the step. That's basically what we're doing. So if you go by running that, basically we get that. So step 0, step 1, step 2, step 3, step 4, and range is 5, so we stop at 4. That's what we've just done now. So that is how the for loop works. So now the for loop, like I said, just to refresh our mind on this, we know exactly how many times we're going to run this. It's going to be a range of 5, not more than that. That's very specific. Now looking at the while loop, that's a different scenario. So what I'm going to do, I'm going to comment that out and I'm going to uncomment this because we're now looking at while loop and how it differ from the for loop. Here I'm setting a condition, which is the condition is that the value of the variable count must be less than 5 for the while loop to keep on running. So you can increase this value to 10, to 100, to 1,000, it doesn't matter. So now I'm setting a variable. We've looked already how to set variables. So basically if you create a variable, it can be any name, but you have to follow the format, and the equal sign, meaning we are assigning the value that follows the equal sign to the variable that we've created. And we're checking while, like you're using a simple everyday English language, while the value of so and so and so is doing this, while we're doing that, while this is true, while this is that, keep doing that, basically. But here it's in a Python code language. So while Python while count is less or equal to 5, so keep doing that. So we're going to take count because the first value of count is going to be 1, so we assign that and it jumps. And remember, Python runs from top to bottom, so it's going to grab that value here. It's here, I know what count is, and I'm going to enter this loop using that. And also notice the indentation, because you cannot have that. It's going to give an error and it's going to highlight that as an issue. The expected indented block required, so you need to have that indented. So, and it says, and that's how Python knows that everything that's under this need to be running. Now, so every time I'm going to run this, it's going to go through print the value count is, which is the current position or current value of count, and then next line is going to run the count. So it's going to say count and add a value, how you add a value to itself. So you could run the long way, which is count is equal to count plus 1 if you want to, but the short version of this is going to be count plus you add a sign plus equal to the value of 1, so it's adding 1 to itself, and you print the value just to see what the last value is before the loop repeats. So if I run that, again. So I'm getting that. So you can see the first time it comes in, it prints 1 and it adds 1, and the value at the end, at the bottom of the while loop, which is this line here, 43, it's going to be 2. Then it moves up again, count, it prints count, it add, and then so on and so forth. And the last value is 6, and it doesn't print anything after that, because by the time it gets back to the test or to validate the condition, the value of count is now greater than 5, and therefore the loop breaks automatically. So Python knows what to do in this context. So we're not bothered about anything else happening after that, unless there is a line of code that goes beyond that. Now, there is a way to go about achieving this same behavior pattern using the for loop, but we're adding a magic word called break. Break is B-R-E-E-E-A-K, which is basically what you would, on a day-to-day life break, meaning taking a break, taking a pause, or just leaving, or whichever way you're using in your life context. Now, we're using a for. Remember, we're using I here as the step. Consider that as a step. So for the current step in this range is 10. So we're going from 0 all the way to 9. So for the current step in this range, if the value of I, as you progress through this range, if at any stage the value of the step is equal to 6, I want you to stop. Don't carry on beyond that. Don't do anything. Just stop. Don't even bother about the remaining value within the range. If you are 6 and there's still 7, 8, 9, don't go up to there. Just stop there. Basically, that's what we're doing. So if I clear my dash and I rerun the code again, you're getting that. So what you're seeing is it runs all the way to 5, which is basically equivalent of range number 6. And it says, well, I've reached 6 and the value of the current step is equal to 6. Time to break. And break simply means just get out of the loop. Don't run the remaining stuff. That's basically the same behavior that you have here, where we kind of setting a condition manually with an if statement, versus in a while loop where it does that automatically. Less line of code, less complication. It's just the same thing, but ideally you want to have a while loop doing the thing for you by itself, instead of having to add an extra logic here that makes things a little bit complicated. All I'm trying to say is use the for loop for what it's used for, and use a while loop for what it's used for. Different tools for different scenario, and that's just what it's supposed to be. Now we're gonna move up to 2 more examples. The one is a timetable, where we're just trying to combine a couple of things here. The only new thing here is that I'm getting a value from the user. So I'm using an input, and input returns a string always. And then I'm just surrounding that with an integer, because at the end of the day, I want to use that to do some comparison or print or multiplication. It just makes sense to have the value of the input be an integer, so that we're not getting any error where we cannot multiply a string with a number or an integer by another value. So that's just a check. So that's a new thing. Print, we've been using that. We're probably gonna get back again to some of these inbuilt method later on. I know it kind of look a little bit like, what is this? New things every time, but let's just focus on the for loop for now and the while loop. And then everything else is just to make the whole process a bit smoother and faster to understand. So now I have my for loop, I have my range. Remember, range, if you're passing 2 values, you pass in the start and the stop. So I'm starting from 1 this time around, and I'm going all the way to 13. 13 means it's going to be 12. So we're always not including the last value in the range. So in every step, I take the first, so it's going to be 1 first. It's assigned the value of 1, and then we do the multiplication, and then we display that. So I'm going to go ahead and run that. I'm going to type that. I'm going to say 3, and here's my table. So it just does a repetition for me. I don't have to do anything else than just watch the thing doing. So there's also another way you can go about maybe passing all the value at once, instead of requiring this to be pass. You can pass all the value ones and have the Python code running it from top to bottom for all the numbers 1, 2, 3, 4 all the way to 9, or maybe doing a loop that does some sort of request every time for a new number to generate a new table with a new multiplication. So really it's totally up to you. Now here comes the fun game at the end. I left it at the end because it's a bit fun and we playing a guess game with or against the computer just to see what we can do. So basically I've used another module here which is also inbuilt in Python. It's random, as you know, random, so it gives me random stuff, but in this case I'm asking for a random integer. So a random integer is how I access it, and I just pass in this run int and I pass in the value to return, which is going to be between 1 and 10, and then I create a variable that take in that value. So we don't know what it is, but the computer knows, and then we create a guess, which is what we are going to try to guess and pass in, and we assign it a value of none, meaning there's no value in it. It's just a null value, 0 value if you want, and we just print a nice text just to say guess the number between 1 and 10, just to know what it is that we're dealing with. And then we enter the while loop. So the condition here is that for as long as the value that I've guessed is not equal to what the computer has selected or randomly picked, the while loop will keep on running now, and it will keep on asking me to guess and updating the value of the guess, and updating and checking and checking and checking until I find a value that matches. And then to make the game a little bit fun, I've added some guides or clues, a way to say, well, if the value is greater than what the computer has selected or picked, give me some clues so that I know which direction to go. Should I increase the number that I have or decrease it? So let's run it and get some sort of fun going on here. So we're gonna run that. So guess the number between 1 and 10. So I'm gonna say it's probably gonna be a 1. Too low, it says too low, so I'm gonna move maybe to 2. It still says too low. It means the number that the computer guesses is probably high. I'm gonna move to 3, for example. Correct, you guessed it right, because the value you guess is exactly that. So I'm gonna run another time, and I'm gonna guess gonna be a 6 maybe. Try again. Too low. Okay, a 9. Yes, 2 guesses. Maybe this could be a fun game, and the less messages or misses you guess can be some sort of score. So if you maybe get first time you get it right, that could be maybe a 10 points or something. I don't know. There are many ways to go about expanding this game and making it fun for everybody else. All right, I hope you've learned something new today. Until next time, goodbye. Bye-bye.